Hello there, welcome back to Backyard Ballistics. Let's go ahead in our restoration journey and take care of this P08 Luger that definitely saw some better days. It is one of two guns involved in a garage flooding, the other one was featured in my latest video. I'm not only going to bring it back to its glorious look, but also cover the functioning of this original and iconic design and share with you another one of my favorite rust bluing formulas. Anyway, let's give it a closer look. The first thing we notice is a thin but extensive coat of rust, more homogeneous on one side and less on the other. If this is the only time this gun got corroded in its history, the surface underneath shouldn't look too bad. However, by looking between patches of rust, especially here at the handle level, I can already see something is off. On these areas I was expecting to see the original bluing, but they instead look much brighter, which suggests this gun had a more troubled life. Also, unfortunately the grips were not only dirty, but one of them seemed badly discolored, so we'll probably have to fix that as well. Anyway, let's get started. I'm no Luger expert, but by the look of them, these grips seem much more recent than the rest of the gun, and I'm quite confident they are modern day replicas. I'll get to them later. After applying a bit of penetrating oil, I was able to rotate the disassembly catch and field strip the gun. As often happens, the inside surfaces are in much better condition than the outside. However, as I gave it a closer look, it looked more and more like somebody had already messed with this gun before. While the bolt seems to retain most of its finish, both the top and the frame of the gun seem to be discolored. In any case, the next thing to do is to derust the part. I'm using the most conservative way of doing it, which is through boiling in water. You don't have to fully disassemble the parts while doing this, and this is a great advantage that will come handy later. However, I still took out the firing pin to see if its serial number matched with the rest of the gun, and of course it didn't. In any case, into the water we go. Now, this whole procedure, including bluing, is not for the impatient. Each boiling is about 20 minutes long, and as you'll see, I'll have to do it more than once, while I'm basically just babysitting the water pot. So you better find yourself something to do while waiting. Talking about that, I've found a mobile game that not only involves guns, but also offers to help a channel like mine to survive by sponsoring this video. Hunting Clash is a free mobile video game focused on the topic of hunting medium and big game. I'm no expert, but I would describe it a bit like a Pokemon game, except you look for animals instead of Pokemons and shoot them instead of catching them. But anyway, each gun is more suited for a certain type of game, and I found it nice that you can actually recognize real-life guns in their designs. Look at this one, it's clearly a Blaser R8 straight pull rifle. This is another straight pull, the RX Helix by Merkel. And can you guess this one? It's an easy one, let me know in the comments. Anyway, aside from guns, there's also plenty of different animals and locations, but I'm much less versed in hunting games, so I'll leave that to you. You can download the game for free using the QR code you see on screen, or by clicking the link in the video description, and if you use the promo code HUNTWITHCARLO following the procedure you see here, you'll get access to a free starter pack comprised of 100 gold coins, 70 skill tokens and 2 mythical lure cards that will allow you to advance quicker in the early stages of the game, unblocking more scenery, animals and hunting skills. All you have to do is download the game and use code HUNTWITHCARLO. Alright, by now our Luger should be cooked to perfection, and I'm using a magnetic stick to fish out the parts. At this point some of the red oxide turned into the black one, and the excess can be easily scrubbed off with some fine steel wool. Together with my last hope of saving the original finish. Look at how blotchy the color is on this side. The dark areas are those that were rusted, and some of that rust converted into the black oxide we see. The lighter ones are instead mostly bare metal, and this suggests that before rusting the surface had already lost its bluing, and I think I know how. Look at the barrel. These, my friends, are one of the most hated marks you can find on a firearm. They are the awful looking effects of a wire wheel. Just like this one. Their bristles are hard and thick, and even at low speed they are harsh enough to scratch gunmetal. And this is almost certainly what happened here. Maybe in an attempt to derust or clean the gun, somebody used a wire wheel against it, ruining it forever. Let me tell you this, there is no gunsmithing job that is suited for this. Just keep them away from guns. Now let's try to save what can be saved. all the outer surfaces of the part are missing their bluing except for the bolt group. On the other hand, the insides are still fine, so what I'm gonna be doing is using a technique that will allow me to refinish the outside only, and most importantly to do it without taking the whole thing apart. If you have ever removed a Luger coil spring, you know what I'm talking about. They are a nightmare to put back in, and I really want to avoid nightmares whenever I can. The technique I'm gonna be using is rust bluing, which incidentally is the same that was originally used for this gun. In fact, Lugers were rust blued until 1936, and this specimen is marked 1921. However, rust bluing is an umbrella term and many different techniques are encountered. The one I'm showing you today is another one of my favorites, not only because it works well, but because it doesn't require any toxic chemical, while many traditional recipes require the use of mercury chloride, which is a highly toxic heavy metal salt. Rust bluing can be applied on top of already existing bluing, and enough passes are able to render homogeneous any existing bluing, no matter how blotchy. However, starting with a more uniform substrate makes things go quicker, so I decided to use some abrasive paste on the surfaces I want to refinish. This will discolor the darker areas and also make the surface look better. Traditional slow rust bluing is very sensitive to dirty surfaces, so thoroughly degreasing the parts is very important. As you'll see, I wasn't thorough enough in this phase, and I'll show you how to remediate. For now, let's prepare the bluing solution. The one I'm covering today is a very old formula called ferro-bronze. It's part of the family of copper-containing rusting solutions, which have some peculiar and cool-looking properties, as you'll see soon. It can easily be made starting from commonly available and mostly harmless chemicals, but requires a few steps. In an upcoming video, I'll cover a much easier rusting solution, so subscribe if you don't want to miss it. I started by adding 4.8 grams of copper sulfate to a beaker. I then proceeded to add about 50 milliliters of distilled water. The exact amount is not important, as long as it's less than 70 milliliters or so. I then warmed up the solution on a hot plate and waited for everything to dissolve. The solution takes on a nice light blue color, and at this point we can add the next ingredient, 0.85 grams of fine steel wool. As soon as it touches the solution, it starts reacting with it, turning red and falling apart. What is happening is that iron is getting oxidized to ferrous sulfate, while a portion of the copper ions are reduced to metallic copper, which is the reddish stuff we see. It is important to warm up the solution, because otherwise not all of the iron will be able to react. Anyway, after a few minutes it's time to filter everything to get rid of the solid particles. What we're interested in is the filtrate, which will be the base of our solution. I filtered it directly into a graduated cylinder where I'll be adding the last two ingredients. First come 4.3 grams of 38% ferric chloride solution. And finally 1.8 grams of 9.6% hydrochloric acid. As you can see, the solution immediately turns to its final grass green color. I then top the solution to 100 milliliters with distilled water and we can bottle it. Up to an extra gram of 9.6% acid can be added in case you see some precipitate forming in the bottle, but other than that, the solution stores indefinitely into an airtight container. Now, with gloved hands, I start applying the solution to the surfaces I want to blue. One peculiar aspect of copper-containing solutions is that they immediately form a pinkish coat of tiny copper crystals on top of the metal surface. This will act as a catalyst during rusting and also give a visual confirmation that the surface has been correctly treated with the solution. This makes sure you're not leaving behind any spot, but most importantly highlights if an area is not properly degreased, like you see here. I wish I could say I did it on purpose, but I just did a sloppy job while degreasing. Those of you that know me are aware that I'm okay on theory, but not so much on practice, since I don't usually do these procedures myself. This lack of experience can be seen in the fact that I'm also using way too little solution. The cotton ball I'm using should be much more soaked, differently than with most other solutions. Anyway, after making sure I had covered all the outer surfaces, I simply let the parts rust on their own in my lab. The next day, this is how they look like. What you see now is a very adherent, fine-grained coat of red iron oxide, just what we need. As usual, I'm using boiling water to convert this oxide into some nice, strongly adherent black oxide. Ideally you want to use distilled water for this, but I've found my tap water is good enough. After 15 minutes of boiling, the part can be taken out of the water. Here you see it compared to an unboiled one. Just look at how much the color changes. This is a sign that we've done things properly. So I'm going to boil the frame as well while I scratch the top. What we end up with is a surface darker than what we started with, but still not dark enough for a good looking bluing. This is normal, and the rusting, boiling and scratching sequence has to be repeated 3 or 4 times. This is the result after the second pass. I repeated the process 2 more times for a total of 4 passes. Here you see me doing the last one, when I had finally realized ferrobronze requires a bit more solution to be applied than other formulas. And this greatly sped up the process, which only took about 4 hours. An important note about ferrobronze is that the hydrogen peroxide trick that I showed in the Carcano rifle restoration video doesn't work with it, nor with any other copper containing solution, so in this case we have no other option than leaving the part to rust naturally. However, if applied correctly, the rusting process is relatively quick and the finish you get is really nice, especially if you're more skilled than me. The bluing process is finished, but it kind of looks like something is missing. I don't know if I was able to pick it on camera, but it kind of looks like the finish is washed out and desaturated. It has no color hue to it, if that makes sense. It just looks grey and kind of dull if we compare it to the bluing we're normally used to seeing on guns. That vibrance is given by one last, very simple but not much talked about treatment. We need to prepare a very dilute solution of copper sulfate. Here I'm making a 0.2% solution of it, just 0.2 grams of copper sulfate for every 100 milliliters of water. The solution takes a very pale blue tinge and it has to be room temperature or colder. Ideally you want to dip the parts in the solution for a few minutes, but as usual I was being lazy and I instead went with a cotton ball. However, I made sure I was wetting the surfaces evenly with plenty of fresh solution and never let it dry. What is happening is we're embedding tiny copper crystals onto the newly formed bluing, and this greatly improves the look, giving a plum hue to the reflecting light. After just a few minutes of continuous swabbing, I quickly rinsed the parts with water and then dried them. It's already looking quite good, but what really brings the new finish to life is oiling. Here I'm using just plain Vaseline oil and applying a generous amount all over the parts. And this is the final result of the refinishing. Some areas are a bit uneven due to regular corrosion damage of the base metal, but there's nothing I can do about it. In any case, I'm done with the metal, and the last thing to rescue are the grips. I'm quite confident these are not original grips, but modern day replicas, but I still decided to try and recover them, even though I could have just bought a new set. Now, the left grip appears to be just dirty, and I was successful in dissolving the mud residues with plain water and a nylon brush. And the underlying wood was in pretty good condition, so I put it aside for now and concentrated on the much worse looking right one. It immediately looked clear that something was wrong though. I don't know what happened to it, but the wood was soaking up water, which suggests the finish is damaged and the wood pores are empty. In fact, upon drying, it reverts back to the washed out color it had at the beginning, and I've got to do something about that. Now what I need to figure out is if only the finish is missing or if the wood also lost some of its pigmentation. You see, just applying linseed oil will restore most of the color as it reduces the ability of the fibers to diffuse light and look bright. It's the same reason why wet clothes look darker and also why you can see through them. However, What color we'll end up with depends on the pigmentation of the wood, either natural or artificial. This is particularly important in my case because I need to match up the color of the other grip as best as I can. By wetting the wood with some lighter fluid, I tried to simulate what the wood would look like if I simply oiled it, and what I got was clearly lighter in color than the other one, which means that I'll have to add some sort of artificial dye to the wood. I'm gonna be using some water-soluble aniline dyes. I tried different formulations on a piece of scrap wood to see which combination would get me to a color close enough to that of the other grip. I ended up mixing two of the stains I had and started applying them in diluted form. I'd rather do multiple light passes to avoid overdoing it. After letting it dry, the color still looked too faint, so I treated it again with the same stain and let it dry one last time. And here is the result. At this point I was pretty confident I had reached an acceptable amount of pigmentation and hoped applying linseed oil would get me to the same look as the other one. Here you see me giving the first linseed oil coat, where a lot of it is absorbed into the wood pores. I did the same on the other grip as well, just to renew it a bit. Even though linseed oil takes a while to dry, the color is almost definitive, and I thought my result was acceptable. Another few coats and I was ready to reassemble the gun. Here's how it looks now. And here's a before and after comparison. Now, of course, we want to shoot these, but before doing that, I'd like to briefly explain how this iconic gun works. You see, this is not your average semi-auto pistol. This gun was designed back in 1898, when semi-automatic pistols still looked like that, and were an absolute novelty, and quite a design challenge as well. The Luger uses a toggle-locked short recoil operation. Let's see what this means in practice. When the bolt is closed, the linkages of the toggle system are aligned with the barrel, so the recoil force acting on the bolt will not be able to produce any torque, and the toggle remains in its straight configuration. This means that the bolt will remain locked to the barrel, keeping the breech shut, but the whole thing is allowed to accelerate backwards under recoil. However, after a short distance, and that's where the short recoil term comes from, these knobs hit a slope on the frame, which pushes them up, causing the linkages to be no longer aligned, unlocking the bolt. By then the bullet has already left the barrel, and the barrel assembly halted to a stop. This way, bolt inertia and residual pressure of the shot will keep bending the toggle, allowing the bolt to move all the way to the rear so that it can perform the reloading cycle. Now, before leaving you with some shooting footage, I want to thank again Hunting Clash for sponsoring this video. Check the download link in the description below. Once again, a huge thanks goes to my patrons, which as usual are all listed here. Thank you all for watching, subscribe if you'd like to see more, and I'll see you next time. Bye.